Okay, so continuing on from video 2, we left off just pretty much describing what those different phases of stage 3 included and what was done. Once they get done describing each of the phases of stage 3 and what was looked at and what was done, they go on to start telling you how they assessed statistically for the different areas of reliability, responsiveness, and validity. So looking down on page 332, we'll start here. And this is where the stats section kind of comes in as well. So at the bottom on the right hand side, bottom of page 332, it says test retest reliability was assessed for all 3 self-reporting outcome measures using type 2-1. We'll just assume we won't go into detail of what this is, but what the focus I want you to get out of this is that test retest reliabilities was assessed for all 3 self-reporting outcome measures using intra-class correlation coefficients and the corresponding two-sided 95% confidence interval to provide an estimate of how closely the numeric scores were to each other. So essentially here what they're saying is that in those phases where they were testing test retest reliability, the inferential statistic that they used was the intra-class correlation coefficient. Now you may ask, what is the intra-class correlation coefficient? The intra-class correlation coefficient essentially assesses the reliability of ratings by comparing variability of different ratings of the same subject to the total variation across all ratings in all subjects. Okay, so when you want to test, if in plain terms of what you should take from that is that if you're looking at reliability, one of the ways to test using inferential statistics to test retest reliability is using a intra-class correlation coefficient, and that is exactly what they did. And to do so, they also use a 95% confidence interval. Now we know what a confidence interval is. So I won't go into detail about that, but just remember, confidence interval is the range of where the true score lies. So they talk a little bit about in that section for test retest reliability, how they assessed how did they assess for test retest reliability. And they also tell you that they looked at test retest reliability for all 3 of those self-reporting outcome measures, so DASH, UEFS, and FL, I'm sorry. And that they use the intra-class correlation coefficient. And just so I can as well, I'll pull up a slide here. I'll talk a little bit about effect size, but so here it is. Intra-class correlation coefficient measures the reliability of ratings or measurements of data collected from groups. Okay? And used for inter-rater reliability. Now let's go back. I want to keep going. I'll keep reading a little bit so we understand a little bit more. So test retest reliability was assessed for all 3 SROMs using intra-class correlation coefficients and the corresponding two-sided 95% confidence interval to provide an estimate of how closely the numeric scores were to each other. Okay? Data was analyzed from the retrospective subgroup participants who completed 2 separate measures, 48 hours apart, during a period of no treatment. So that was the subgroup where they did the initial assessment, and then 48 hours later they did the same. They gave them the same self-reporting outcome measures, all 3 again, but with no treatment provided in between those times. All subjects completed a participant's detailed form, the ULFI, DASH, and UEFS, the SF36, and 11-point VAS for functional status on initial testing. So they provided the 3 self-reporting outcome measures, the FS36, which is another one, and the 11-point VAS for functional status on initial testing. So that's how they're testing them. This was reported on the second occasion with the details form replaced with the MC13. So they changed one of the forms. And a further 11-point VAS scale for feedback in 4 areas, which was completion ease, confusion, explanation, and the RSOM's reflection of their condition. So they're not only looking for the patient feedback, but they're looking to see at how easy was it for all of those patients to complete each of those self-reporting outcome measures, if it was confusing in any aspect to complete them. Explanation, and then reflection. Do the outcome measures reflect the condition? Okay. So they just kind of continue to go on and tell you about that. Now, let's look at the measurement error section. Measurement error. We always have to measure, we always have to assume that there might be error, right? We've talked about this previously. So in this case, they used a particular statistical formula called the SEM, or is also known as the standard error of measurement in the MDC at 90% and 95% confidence interval levels. Let's take a minute and talk about what that is. First and foremost, let's talk about what standard error of measurement is and why we use that. Standard error of measurement estimates how repeated measures of a person on the same instrument tend to be distributed around his or her true score. So a true score is always unknown because there's no measure that can be constructed that will actually provide a perfect reflection of what that real true score is. So we have to determine where that true score fits and what is the chance of error. The standard error measurement, or the SME, is directly related to reliability of a test. The larger the standard error measurement, the lower the reliability, and the less precision there is in the measures taken and the scores obtained. Now, the higher the reliability of the test, that means there's more precision, and that means that the standard error measurement should be smaller. Since all measurement contains some error, it is highly unlikely that any test will yield the same scores for a given person every time they are retested. But nonetheless, we have to test for error. So when they were testing test-retest reliability, since we need to determine what the error is, what is the potential for error, they decided to use the standard error of measurement, which is directly again related to reliability of a test. So this section, measurement of errors, where they describe and talk about how they determine what was considered error and where the true values actually lie. Now, let's talk a little bit more about what else you see here. You see MDC at the 90% and 95% confidence intervals. Well, what this means is minimally detectable change. Let me pull up my PowerPoint again. Minimally detectable change essentially means what is the lowest amount of change that has been considered for an assessment to be statistically significant. So early in the article, they said that for the DASH, the MDC was 10.7%. So in order for a change to be determined as statistically significant, the patient has had to have a change from either the first time doing the assessment to the next time of a 10.7% change. So if we just think about that in points values, if we said that in order for the DASH, it's a 2.5 point, that's 2.5 points. that patient needs to show a change of 2.5 points from the last time they took that exam for us to say, okay, there is a definite change, because that is the minimally detectable change. That is the defined minimally detectable change in order for us to say, yes, that is a statistically significant change. Okay? Now, they're providing you with two different confidence intervals, and you will see that often. So when you see the MDC 90, that's just telling you that the minimally detectable change is based on a 90% confidence interval. And if you see the MDC 95%, that's just telling you that that minimal detectable change is based, that should say 95, not 90. It's based on a 95% confidence interval. So in the article, they're telling you that they calculated the standard error of measurement, and they also calculated what the minimal detectable change should be, and they calculated it at both a 90% confidence interval, and they also calculated it at a 95% confidence interval. Okay? And to do so there are two methods to achieve these values. So in order to calculate the minimally detectable change, they used a Cronbach alpha, so just a CA coefficient for eternal consistency, or the test-retest reliability coefficient. These are additional statistical inferential statistics that you can use to calculate these things. And I believe I only talked about the CA here in this PowerPoint, where the CA is a complex statistic used to measure internal consistency for reliability, and is used for multiple level responses, such as an example I provided, a test with multiple items that ask the patient to rate their responses between 1 and 5. So in this case, that definitely fits the DASH, that definitely fits the ULFI, and the UEFS. Whew, that was a lot to take in. So let's go back and say what we're talking about. Now, earlier, they talked about testing for retest reliability. And within that, to test retest reliability for all three of the outcome measures, they used the intraclass correlation coefficient to test retest reliability. Well, it's not enough to just test retest reliability using that intraclass correlation. We also have to test for error so that we know whatever answer we get using that intraclass correlation, that true value, we know where that true value fits. So we need to know how much error is allowed before it's not reliable. Now, to test for error, they use the standard error of measurement, and they also calculated the minimal detectable change. And to do so, they used another statistic called the CA coefficient. And they also used the test-retest reliability coefficient. Okay? Woo! All of that just to figure out if there is reliability. But that's what they did. Okay, so I'm not going to read that in detail, because that's essentially what they're telling you, and then they go on to tell you exactly the values that they came up with. What I would like to note a little further down here, now we're still looking at measurement of error, where it says SME subsequently provides MDC 90 and MDC 95, where the tabled z-values are respectively 1.65 and 1.96 at the 90%, 95% confidence intervals. This calculation can be interpreted as the magnitude of change compressed in either scale points or percentage basis required to be 90% or 95% confident that the observed change is real and not measurement error. So here's the famous z-values from the z-distribution table. And just showing that they had to use they did use the z-distribution table to determine the magnitude of change. So we're going to keep going. So again, just to kind of recap, they tested for test-retest reliability, and they used the interclass correlation coefficient, and then they still had to test for error so that we could know that we are 90% or 95% confident that the observed change is real and not a measurement error.